Hello, I'm Claire and I'm physics and chemistry teacher in the west of France. For EUSMI competition, my students made experiences about soft matter. So they made researches on the internet about these experiences, and then they wrote a protocol in English, and they share today the videos that they have made with you.
Hello everyone, today we will do the experience of maizena. We do this experience to show the property of maizena.
You need 100 milligrams of corn flour, about 50 milliliters of water and a beaker. Pour the corn flour then the water into the beaker and finally mix it all together. Add more water and corn flour according to the state of your mixture. Corn flour is composed of corn starch, which when composed with water becomes a well thickened fluid and therefore a liquid when handed slowly and very viscous or even solid if handed quickly. It is a non-Newtonian fluid.
So, for this experiment we need a plastic bag and a sharpened pencil and water. So, we fill a plastic baggie with water, we seal the baggie, we quickly stab a sharpened pencil to the baggie. We try stabbing multiple pencils to the baggie. Why the water doesn't leak?
How does the experiment work? The magic of this experiment lies in polymers. Polymers are long chains of molecules that make up many items we use in our everyday lives, specifically plastic items.
Plastic badges like the one used in our experiment, plastic grocery bags, plastic water and soda bottles, or plastic food packaging and are all made of polymers. Products made of polymers are flexible, lightweight, leak-proof, and low in cost to produce.
Think of polymers as long chains of beds.
When you stab pencil to the bag, the polymers move apart. This is the same as if you stuck a pencil between two chains of beds. Because polymers are flexible, when you stab a pencil to the bag, the polymers push back toward the pencil and form a temporary seal.
This prevents the water from leaking out of the holes. If you remove the pencil from the bag, the holes will remain in the bag because you have permanently pushed the polymer aside, allowing water to leak out.
It is sometimes called the lotus effect because it happens on the leaves of these plants that use it to rest underwater.
No, you can even find a spray that makes a surface super hydrophobic. Unfortunately, we were not able to get some, so today we will use soot for our experiments. We simply burnt the lid of a jar of jam. Then we can pour the water on it and let the magic happen. Actually, the common point of all these super hydrophobic surfaces is that they have a very high nanometric roughness. Because of this, the contact points between the water and the surface are very weak, so the water can spread on the surface.
When the surface is less rough, the water tends to spread on it because of the energies of interaction with the material. But if the surface is very rough, these energies of interaction are replaced by the cohesive force and the surface tension of the water, which leads it to stay in a round form. To distinguish the different kinds of surfaces, we measure the contact angle between the water and the surface. Because of the surface tension, a drop of water wants to minimize its surface, so it takes a round form. At the contact of a surface, the drop of water creates a contact angle, and if it is superior to 150 degrees, it is super hydrophobic.
Thank you for your attention. Now it's time for you to make this experiment at home. Goodbye.
guys, today we are going to experiment magnetization in different liquids. So to do this experiment you'll need a spatula, paper clips, a magnet, and different liquids as water, oil, and dish liquid.
So you take paper clips, you put it in a liquid like that, and that. Here you can see it don't go until the bottom. So you can take a spatula and push it. So you can take the magnet and go next to the beaker. You can see it is working, the magnetization is working. And like that, we have the paper clips just on the magnet. Then you can go to the oil to see what is going to happen. It's the same thing. Maybe a little. No, it's the same thing. It's working. The paper clips.
Right now you can do the same thing with the dish liquid. So you take your magnet and you try to put it next to. But as you can see, it's not really useful. The paper clip don't want to come. It's not working.
Well, we enjoyed a lot to take part in this competition. We hope that the experiments will be useful and that your students will be able to carry out the same experience. Alright, goodbye and stay safe.